Hello everybody, in this tutorial we're going to learn how we can process the export PDF or DXF or TWG into the PartWorks to develop the profile toolpath. So as you saw here in the last tutorial, we developed the PDF for this. Now what I'm going to do is I'm just going to create a new file in the PartWorks. Now everything will happen in the PartWorks right here. I'm going to create a new file in the PartWorks. I'm going to say width is going to be 8 feet, which is 96 inches, 48, which is going to be 4 feet. The material thickness that I have is it's 0.5 that I got it from the market as 0.5, but ideally if we see it's not 0.5, it is 0.485 or 0.449. So I'm gonna do is I'm gonna put 0.49 here. I'm gonna say use origin offsets, keep it in inches. Perfect. Now my material has been set up. Now I'm gonna use import vectors from a file. You can do it from here or you can do it from here as well. I'm gonna do import. So this is the right file that I'm gonna use it here. Now as you can see that, so I'm gonna rotate this design and put it at the 90 degree, and let's see how I do that. I'm gonna pick the rotate vectors. Let us say 90, and let's say okay. Now if I zoom it in, I'm gonna go here. Alright, so now if I zoom it in, I see that this profile is perfect, but I want this to be a part of it as well, which is not. So I have to join this. If you guys are new to this tutorial, you can always go back to my website and we'll check how to process the vectors tutorial, and you will see how you can join it in. I'm just gonna join here real quick. I'm gonna select this, holding the shift button. I can select multiple vectors, and I have selected that. I'm gonna hit the join button here, and as you can see, close is 1 and open is going to be 0 vectors after joining. Current vectors, 4 vectors are currently open, but now if I click on this, that entire pieces join in one object. I gotta do exactly the same here. If I think that I should be reducing the labor, I can copy this and paste it here. Alright, perfect. As you can see, I have this one piece, I have this one piece, I have this, and I think it. Well, in this case we need grooves here, and if I put exactly this way, it's not going to work. So I think I need to mirror that, because I need grooves both sides of my design. So I'm just gonna get vertical. Perfect. Now let's see how we can prepare the toolpath. So I'm gonna bring up the toolpath menu here, and let's see if we all can see this object, and this object is gonna be the outer profile, outside cut. So I'm gonna select them together and just make a group real quick, so I don't have to pick them separately all the time. So now they're grouped. I'm gonna go here, create a profile toolpath. First thing I want to make sure here is that my vectors are outside profile. 0.5, I'm going up to 0.52 because my material thickness here is 0.49, which I'm expecting it to 0.5. So just to cut all the way through, I'm gonna pick 0.52. I have ML, which is a 1/4 of an inch in diameter. I'm gonna use this 0.25. Well, here the pass depth details. How am I gonna use this? Is if you will go to the vocabulary sections on my website, you can see how we can decide the cut depth. The pass depth. So the pass depth equals to cut depth divided by number of passes that you guys expect to cut your design within. So, and again, whatever the result is, that it should be less than the diameter of your bit, so it should be less than 0.25. So what am I going to do here is I'm going to quickly get the details using the calculator. So if I see here, I'm going to do 0.52 divided by 3, and it gives me 0.17333, which is okay, perfect. Let's see if I can cut it into 2 passes so I don't have to wait that long. Well, let's see what it gives me. I'm gonna do 0.52 divided by 2, which is 0.26, which is bigger than the diameter of the bit, so I'm not gonna use this. It's not good. It can break the bits, and breaking the bit could fumble the bit outside the gantry, and it could hurt someone. So always be careful with these details. What am I gonna do? 0.52 divided by 3, which is 3 passes at 0.17333, and that's the exact thing that I'm gonna put here. So I'm gonna do 0.173. It's gonna be a pass depth. Step over. You can see in the details about step overs in the vocabulary section. I'm gonna put it to 60. It shouldn't be a problem. Feed rate, Shabbat user manual recommends that the starting feed rate could be 1.7 inches per second. Make sure it's inches per second, not inches per minute. And the plunge rate, you can start with 0.3, 0.5. I'm gonna use 0.4 here. The feed rate is, I'm gonna keep 1.7. I'm gonna give a further detail about feed rate, plunge rate, and pass depth in the future tutorials. So make sure you do the right pass depth, which is a cut depth divided by number of passes you desire. So if you want 3 passes, divide 0.52 by 3. If you have 4 passes, divide 0.52 divided by 4. But make sure in each situation the result should be less than 0.25, which is the diameter of the drill bit. Apply it, press OK. I got that. Second thing we're gonna do here, we're not gonna play with a lance offset here. If you want to know more about that, look at the vocabulary section and a lance offset. I'm gonna use tabs. I'm gonna do 0.35, 0.35, which is a standard that I use, and it works perfect all the time. Having the thickness 0.125 or a little less than 0.35 can cause a situation where you're machining and in the middle of the machining you lose your tabs and your part will be moving around in the middle of the machining process, which is not good. And I have seen a lot of students losing their material or damaging the material just because of that. So be always aware about that. I'm gonna go to edit tabs here. I'm gonna make sure where I need the tabs. I'm gonna put one here. Okay, I haven't selected it, so it's just not allowing me to do that. Go to edit tabs. I'm gonna put one here, one here. I'm gonna put one here. So putting up a tab is a little tricky part. Make sure you put the tabs in the areas where you can remove it easily and quickly. And I think that should be enough for the design. Now I'm just gonna give it a name. I'm gonna say outside profile cut 1. Where's it calculated? It's gonna warn me that the material thickness is 0.49 and the maximum tool depth is 0.520. We're just gonna cut through the material. Well, exactly that's what we want in this case. So say OK, and you have a preview mode in 3D view. If you want to preview a toolpath, you can see how it looks like. I recommend you guys to always make sure whenever you make this, if you check on this little box here, you'll be able to see is it outside or inside. So this purple line or pink line is your design, and this line with arrows is the toolpath, whereas where the tabs will be generated. So you always make sure whatever you selected here, outside, inside, or on, is it here or no. If it's not here, it's not good. So far, one down. Now this 2 profiles here, it's gonna be more like an inside cut. So I'm gonna holding a shift button, select both of them, and I'm gonna make a group so I don't have to pick them all the time. So they're grouped now. I'm gonna go to create profile toolpath. First thing I'm gonna do is inside tool. I'm just gonna make sure that everything is correct here. I'm gonna do an anmil 0.25, 173, apply, okay. And here I'm gonna add it to the tabs here. I'm gonna put one here and one here, and one here. And once I've done this so far, it's good. I'm gonna say inside cut profile 01. I'm gonna calculate this. It's gonna want me again that you want to cut it all the way inside. I'm gonna say yes because I want to cut it through. Say okay here. I'm gonna preview that toolpath. So as you can see, it's been chopping perfect, nice and clean. Holding two little tabs here that I expected. Watch this is here. So far I'm done with now this two little lines here, which is gonna be the groove here that I'm gonna select them both, holding the shape button, and I'm gonna click on the groove vector. I would go again, I'll close this and go again to create profile toolpath. At this time I'm gonna pick on machine vector. I'm gonna click on. Again, I'm gonna pick ml 0.25. I'm gonna make sure all the details are same. But this time I have to change something. Or what's gonna be that? Well, I don't want it to cut all the way through. I want it to go only 0.25 because it's just a groove. So I'm gonna say cut depth only 0.25. When I select the hand mill 0.25, what I'm gonna do, put 0.125. Well, why I'm picking 0.125? Because I'm doing the calculation here. That's 0.25 divided by 2, which is 0.125. You can try 0.25, just direct past that to 0.25, but it's exactly as the diameter of the bit. That just increases the chances to break the bit. Using 0.125 here, I'm gonna remain on the settings as it is. The spindle speed in all the cases commands it should be 18,000 and around, but changing here in our case is not gonna affect, because if you go to the vocabulary section, we have a Shabbat that has a spindle that changes the speed manually. That has a little switch on the spindle that changes. So if you change it here, it's not going to make a difference. So it's not going to affect the spindle, because this little area is not connected to Shabbat from here. But there are certain motors available in the higher class of Shabbats, in which if you put it here, it's gonna change it there, or it's gonna get applied on the spindle, but not in our case. So far we okay, and we don't need tabs here because it's just a regular groove. I'm gonna give this name as machine vectors 01 calculate, and as you can see it now, I'm gonna preview the toolpath. So what it did, it just developed the perfect groove that I wanted. Now, as you can see, it shows new here, and I have done all the process. A lot of people make a mistake here and they don't save it, and if you haven't saved this data, it's not gonna help you to come back to this file again and make corrections if you need to. Say for example, your speed was fast, or maybe you forgot to have some tabs, or maybe you want to change your tab depth. You need this file for that. So what you do, file, save. Just gonna save as a CRV file. What I'm gonna do is, and I'm gonna save it, this is the PartWorks format, CRV, save it here. Well, saving the CRV is not gonna generate any data to machine on the Shabbat. So you can see a little button here called Save Toolpath. Hit that button. Make sure you check all the boxes here. If you don't check these all boxes, as you can see, nothing shows here. Toolpaths to be saved, no visible toolpaths. In this case, you have to check this all. A lot of people do a mistake here, output all visible toolpaths to one file. So make sure you check that, because if it's not visible, it's not going to check it in. So this needs to be checked, and this all needs to be checked as well. Now we have two different kinds of Shabbat. That's cool. We have one, it's a Shabbat Buddy, and one is a big Shabbat, 8 feet by 4 feet. Well, for Shabbat Buddy, the small Shabbat, you can use arc inches with speed, because that machine has a capability to machine your parts with speed. The old Shabbat has this little format called Shabbat arc inches. So for old Shabbat, number 3 from the top, and for the new Shabbat, Shabbat Buddy, it's gonna be the top one. So let's select this, save toolpath, and I'm gonna say for side parts, and I'm gonna save it. Now you see what it format it's saved in is SBP, and I'm gonna use that format on the Shabbat control software to machine it. Alright, that's pretty much, I guess. If you have any questions, feel free to reach me. Thank you for watching.